So we're going to skip ahead to chapter 12 just because it's going to be a shorter unit and we are so close to Christmas break. In chapter 12, we're going to go over complex numbers and matrices. So there's really just two big topics in this chapter, and we are going to start with complex numbers. So complex numbers are based on a number whose square is -1. So up until this point, when we'd been working with the quadratic formula, when we got a negative number in the square root or the discriminant, we just stopped there. We said there was no real solutions and we didn't go any further. Now, with the imaginary unit as a tool, we can now simplify that problem even further and actually get an answer in the imaginary number range. So the imaginary unit I is the complex number whose square is -1. So what will be important to know when solving problems is that I squared is equal to -1, and I is the same thing or is equivalent to the square root of -1. So when we're taking the square root of a negative real number, the general rule here is that for any positive number a, the square root of -a, we can then split off to say is equal to the square root of -1 times a, and then split that off even further, since we now know that the square root of -1 is I, and just say that that number is I square root of a. So this might look complicated, but seeing it in an actual example, it's not as weird as it looks. So for example, let's say I have the square root of -5. What I'm going to do here is I'm going to split this off to say that this is the same thing as the square root of -1 times the square root of 5. I now know that the square root of -1 is just I, so I can rewrite this as I times the square root of 5, or to put it, and I would be done. So another example we'll look at is simplifying the square root of -18. So here we're also going to be thinking about if that number itself simplifies even further. But first I see a negative number. I'm going to want to pull that out. So I'm going to say that's the square root of -1 times the square root of 18. From there, I'm going to ask myself, can 18 simplify anymore? Are there any perfect squares that go into it? I can see that 9 would go into there, so I'm going to simplify this even further by splitting that 18 off into the square root of 9 and the square root of 2. And then finally, I'm going to simplify everything from there. This is going to simplify to I, square root of 9 is going to simplify to 3, square root of 2 is going to stay as is because that won't simplify any further. And to write this in proper form, I'm going to say this is 3i times the square root of 2. So the general way that we want to write a complex number is in this form, a plus bi. So we're going to write the real part first and then add the imaginary part in the end. So when we're like adding or subtracting these, it'll be important to just kind of know that form. So when we're adding and subtracting complex numbers, so let's say for example, I want to find the difference of 5 minus 3i minus the quantity -2 plus 4i. I'm going to just treat this as a regular equation. I'm going to combine like terms. Here you want to think of the terms as real numbers are going to combine and imaginary numbers are going to combine. And once I simplify it and combine everything, I'd be done. So here, since I'm subtracting, I'm going to want to carry out the negative. And I'm going to rewrite this to say 5 minus 3i minus -2 will change to +2. And then minus 4i. So from here, I'm just going to want to combine my real numbers, which is 5 and 2. And I would want to combine my imaginary numbers, which is -3i and -4i. And then all I'm going to do from this step is combine the real and imaginary. 5 plus 2 will be 7. -3i minus 4i will combine to give me -7i. And I'm done. So the last thing that we're going to do today is tying this all together and actually solving the quadratic formula equation where you would get irrational numbers as your answer. So here I want to solve x squared plus 4x plus 5 equals 0 using the quadratic formula. So right out the gate, I'm just going to write down what my a, b, and c values are. And now I'm going to use the quadratic formula to solve. Just a reminder, quadratic formula is this. So when I'm using the quadratic formula to solve, I'm going to plug everything into my equation. Say negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2a, which will be 2 times 1. So when I'm simplifying this, I'll have negative 4 plus or minus. Everything in that square root is going to go down to be negative 4 all over 2. So in chapter 4, if I had a problem like this, I would just put my pencil down and stop here because I had a negative number and I couldn't get a real answer. But from here, what we're going to do is simplify this square root using what we now know about imaginary numbers. So I'm going to pull out that negative and change it to an imaginary number. So what I'm going to do is simplify this. So I'm going to rewrite this equation as negative 4 plus or minus. I'm going to split this off to say negative 1 times the square root of 4 all over 2. And then I know that the square root of negative 1 is I. So I'm going to write it like that. And the square root of 4 is 2. And then finally, from here, writing this in the a plus bi form, I'm going to divide the 2 on both sides, or in both parts. So this is finally going to simplify. My final answer is going to be negative 2 plus or minus I. So that would be my answer to that quadratic formula equation. Again, they're not real answers. They would fall under the imaginary realm, and those would be the answer for it in its general form.